Okay, so now let's look at this example. So the following data have been estimated for two mutually exclusive investment alternatives, A and B, associated with a small engineering project for which revenues as well as expenses are involved. They have useful lives of 4 and 6 years. See, for option A, the useful life is 4 years. Option B, useful life is 6 years. So the useful lives of these two options are different. And the MARR is 10% per year. And which alternative is more desirable? Okay, so they want you to use the repeatability assumption, which means you need to find the LCM of 4 and 6 first. What is that? It is 12. Okay, so 12 years is gonna be your study period. And now you can use the repeatability assumption, which means you can extend the option A by repeating the cycle of 4 years for 3 times. So 3/4 is 12, so that you can extend the timeline of this option to 12 years. And for option B, you can repeat the cycle by twice, okay, by 2 times, which means 2 6 years will be 12 years. So that's the method we're going to use. Okay, so let's divide this to 2 parts. And for A, okay, so let's just draw the first 4 years. We know that at the beginning you need to pay 3,500 to buy the equipment maybe, and every year you have annuities of 1,255. Okay, and then we said we want to use the study period as 12 years, which means you need to repeat this cycle for 3 times. So 5, 6, 7, 8. This is another cycle, but you need to pay the same price for the same equipment. So you need to pay at the end of the first cycle, you need to pay the same 3,500 for the same equipment. And then every year after that, you're gonna have the same annuities. Okay, and then you're gonna extend another time. So that the whole timeline will be 12 years, okay? Which means at the end of the second cycle, you're gonna pay the same price to buy a new equipment, and then after that, every year you're gonna have the same annuities. Well, this is how you extend this shorter timeline, shorter useful life to the study period using the repeatability assumption, okay? And then now it's option B. The first cycle is 6 years. At the beginning, you want to pay more. That's more expensive equipment. But every year your annuities will be greater, which is 1,480. And you want to extend this for another time so that you can reach the 12-year study period. Okay. Which means at the end of the first cycle, you need to pay the same price for the same machine. And after that, every year you're going to have the same positive annuities provided by the machine. Okay, so this is how you use the repeatability assumption to extend the shorter useful life to a longer study period. Okay, And then you just need to convert all the cash flow to the present worth and compare the present worth of A and present worth of B to see which one is bigger. Okay, so to convert the cash flows for A to present worth, you need to see, you want to have the present worth A. It consists of several parts. So PW1 is from the first 3,500 at the time 0, and you want to convert the present worth to present worth. PW2 is the other 3,500, but it's at time 4, so it's a future value want to be converted to present value. PW3 is the third 3,500 you paid at time what? Time 8. So still it's a future worth converted to present worth. And the PW4 is all the positive annuities. Okay, for how many years? 12 years. So it's to convert the annuity to present worth. Okay, and then you just need to calculate the PW1, PW2, PW3, and the PW4. Okay, PW1 you don't need to convert because it's already present value. So just copy that value here. PW2 you need to use the formula convert future value to present worth is F times P/F MARR and N. So that is 3,500 times the P/F 10%. How many number of years? It's from the time 0, it is 4. Okay, so I will skip the calculation. Okay, I'll just write down the formula. PW3, still it's a future value converted to present worth, so the formula is the same. But the difference is the time, that how many years you want to, consider is different. It's from the end of the 8th year. Okay, so the number of the value of N is gonna be 8. PW4 is positive A P/A MARR N positive 1255 P/A 10% 12. Okay, so after you find out the factors and the calculation, you're gonna have the PW equals to the sum of these 4 parts. And the final result is positive 1027.9435. Now let's do the present worth method for option B. Okay, so you wanna have the PWB, and it's consists of 3 parts. PW1 is from the initial payment at time 0, so it's P converted to P, and the PW2 is another 5,000 at time 6, so it's a future value convert it to P. And the PW3 is the positive annuities for 12 years. So it's to convert annuity to present worth. And then you need to calculate what is PW1, what is PW2, what is PW3. So PW1 is 5,000 negative. PW2 is to convert a future value to present. So its formula is F times P slash F MARR, and it's 5,000 P slash F 10%. How many years you need to consider? It's this value. It's at the end of the 6 years, so the N is 6. PW3 is to convert the annuities, so the formula is A times P slash A MARR N, so it's positive 1480 times P slash A 10% 12. Okay, so after you calculate all of this, you're gonna find out PWB is the sum of PW1 plus PW2 PW3, and then the final result is 2261.776. Okay, so compare these two values. Which one is bigger? Of course, the PWB. So PWB is bigger than PWA. So you want to choose B as a better option.